All right, guys, welcome back. We are on section 2, and today we are only going to cover the first half of section 2. And so what I'd actually like for you to do to start off is complete this warm-up quiz. So if you have not already done that, go ahead and do that now. You can pause the video and come back once you have that completed. And then once you hit play on the video, I will have the answers for you so you can check and see if you have them done correctly. All right, here are the answers for you if you want to pause and read yours and see if you got them done correctly. Remember, converse is when you flip the hypothesis and conclusion. Inverse is when you negate both, so not. Contrapositive is when you do both. The hypothesis is the very beginning. It does not include the word if. And the conclusion is at the end of the sentence. It's the part after the then. It does not include the word then. And then, of course, the biconditional is when you take out the words if and then. So remember, I told you guys basically just scratch those out. And then in between there, where the comma is right here, is where you put the if and only if. So double check that you got all those right. And if you did, feel free to move on. We are going to be, again, doing section 2A. We'll do section 2B tomorrow. So today we're going to be talking about inductive reasoning. Tomorrow, or 2.2B, will be the deductive reasoning. So again, today is inductive reasoning. And then we're also going to be talking about the validity of an argument and the counter example. So a counter example is an example that goes against. So a counter argument or a counter example, an example that proves something is wrong. So we're just going to start off with some kind of easy questions here. First one says sketch the fourth figure in the pattern. So notice we have 2 on this first one. Now we have 4. Now we have 6. So the next one would have 8. 1, 2, 3. So that'll have 8. And then, of course, we're going to color in the first box there. All right, next example we have describe the pattern of numbers, -7, -21, -63, and -189. So from there you can see that each one is going up by a multiple of 3. So it would be multiply by 3. Now notice I didn't say multiply by -3 because it is not changing from negative to positive to negative to positive, right? It's staying all negatives. So we're multiplying by a positive 3. And then I'm going to go through and multiply the -189 times 3, gives me -567. And then 1701 and -5103. So those are the next 3 numbers in the pattern. All right, next we're going to talk about what is a conjecture. So a conjecture is kind of like a hypothesis. So like in science class, when you kind of guess or you make a conjecture or a hypothesis, it's something that's not proven, but is usually based on observation. So when you hypothesize, usually it's like making an educated guess, right? You look at something that has already happened and you start to hypothesize or make a conjecture about that pattern repeating, basically, right? So if on Fridays you see that all of your teachers wear jeans on Fridays, which you wouldn't see that this year, but if you see every Friday we're wearing jeans, you might say, oh, well then I guess they're having casual Friday on Fridays for teachers, right? So that would be like a conjecture or a hypothesis, just based on something that you see happening. All right, inductive reasoning is when you find a pattern in specific cases and then you write a conjecture for the general case. So like exactly what I just said, you notice something happening over and over again. I keep seeing the teachers are wearing jeans on Fridays, right? Then your conjecture is, in general, I bet Fridays are casual Fridays. So you make a conjecture about the general case, not that specific case, like not today Friday, but all Fridays I'm noticing that teachers are wearing jeans. So it must be, in general, teachers get to wear jeans on Fridays. So let's do this example here. So it says numbers such as 3, 4, and 5 are called consecutive integers. So when they're in a list, 1, 2, 3, or 3, 4, 5, whatever, that is consecutive. Make and test a conjecture about the sum. Remember, sum means to add, of any 3 integers or consecutive integers. So let's just start with the one they listed. 3, 4, 5. If we add those together, we get, what is that? 9 plus 3 is 12. Okay, so we get 12, sure. Let's do another one. 1, 2, 3. That's 6. And let's do something bigger. 10, 11, 12. That would be 33. Or let's do some negatives. -4, -3, -2. That would be negative, what is that? 5, 6, 7, 8, 9. -9. So we want to make a conjecture about what we're noticing here. So let's look at all these answers. What do you notice about all of my answers? What do they all have in common? They are all divisible by 3. Do you see that? 12, 6, 33, -9, all divisible by 3. So I'm noticing, I see a pattern that in these specific cases, these 4 cases right here, that all of those numbers are divisible by 3. So what I would do is make a conjecture that in general, if you add any 3 numbers that are in order, if you add any of them together, you're always going to get something that is divisible by 3. Let's check something like way bigger. How about 1,000? Let me not put a comma there. Let's try 1,000, 1,001, and 1,002. If I add those together, I get 3,003, also divisible by 3. So no matter what numbers you add, if they are consecutive, one after another, then if you add 3 of them together, they're divisible by 3. There you go. So I made a conjecture about the general case. That's inductive reasoning. All right, so make and test a conjecture about the sign of the product of 3 negative numbers. Any 3 negatives. So it doesn't have to be in a row. So I'll do -5. Now it says product, right? What does product mean in math? It means to multiply. Times -1 times -2, let's say. So that would be -10, right? All right, let's do -2 times -3 times -7. So that would be 6 times 7 is 42, so -42. What do you notice? You probably already could have guessed this, right? Do you see how always the answer is negative? So I would say my conjecture is that the product of any 3 negative numbers is always negative. There you go. All right, next, we're going to talk about disproving something. So if I say, hey, every Friday teachers wear jeans, and then you see a Friday where we don't, like maybe it's WWF and it's one of the Fridays where it's a dress up day and we don't wear jeans, right? And so if you're going to go against my conjecture, you're arguing with me, basically saying, no, I don't think you're right. The reason I think you're wrong is because did you remember that Friday from WWF, right? And so your counter example is that thing that argues with the person. So the counter example is a specific example, right? Like one time that it happened, give me a very specific time when the conjecture that the person made is false. So it goes against what they're claiming. Okay, now it has to be a specific case. You can't just say, no, sometimes teachers wear like a skirt on Fridays, right? Can't say that. You have to say one specific case, like this exact day, they did not wear a skirt, therefore that cannot be true, right? So let's look at an example here. So a student makes the following conjecture about the sum, so when you add them, of 2 numbers. Find a counter example. So come up with something that goes against this student's conjecture. So they claim that the sum of any 2 numbers is always greater than the larger number. The sum of any 2 numbers, okay, let's start there. 3 plus 4, let's say, is always greater. So the sum of these numbers is always greater than the larger number. So here's the sum. Is it greater than the larger number? Is 7 greater than 4? Yeah, it is. Okay, so that's not a counterexample. That actually agrees with them, right? Let's try something different. How about 0 plus 11? Well, that equals 11, right? Is that answer, is 11 greater than the larger number? It's not, is it? That number, the total or the sum, is actually equal to the larger number. Do you see that? And so this right here would be a very specific time when their conjecture is false. Okay, so this right here is a counterexample. Let's see if we can come up with something else. How about Ooh, let's try negative. How about -5 plus 3? Now, what does that equal? That equals -2. Is the sum greater than the larger number? Is -2 greater than 3? Nope. So there's another really good example, right? You see that the sum is actually smaller than the larger number. So either one of these would be a counterexample because it is a very specific case. It's not just saying like, oh no, if it's negative, it's not that way, right? It's a very specific case when it is false. Okay, so you cannot write a sentence saying if the sum of the numbers has a negative number in it, then it won't be greater than it. You have to show me the numbers, show me the specific example when it is false. All right, we're almost done actually. Let's try another one. So find a counter example. So give me one specific time that it is false. It says the value of x squared is always greater than x. The value of x squared is always greater than x. Okay, so let's say that x equals 5. So is x squared greater than x in this case? Well, 5 squared greater than 5. Well, of course, 25 is greater than 5, right? So that works. So that's not a very good counterexample because that's true. We want to come up with something that's false. What do you think, guys? What can make this false? Let's try something else. What do you want to try? Should we try a negative? See what happens. How about we do x equals -2? No, actually, I don't like that. Let's do -3. Okay, so that would mean that -3 squared is greater than 3. And we want this to be false. Remember, that's our goal, is to come up with something that argues with them. So they're claiming that this is true. Let's see, -3 times -3, or -3 squared is 9, which is greater than 3. So dang it, we came up with another true example. What else could we try, guys? We could try, how about we try 1? Should we do 1? Let's see what happens here. Okay, if x equals 1, then 1 squared is greater than 1, which is 1, which is greater than 1. Oh, that's false, right? 1 is not bigger than 1, it's equal, right? So here you go. Here is a counter example. When x equals 1, this up here is false, right? And so this right here is my counter example. If x equals 1, it's wrong. Are there any others? What about 0? I bet 0 works. Let's try it. If x equals 0, then 0 squared is greater than 0, which is 0 is greater than 0. Again, false, right? So if x equals 0 or if x equals 1, those are both counterexamples. Now, you don't have to have 2, but there's another option. All right. This is our last slide here today, which is basically just checking in. Did we cover the things we said we would cover? So we said we would talk about inductive reasoning. Remember, we talked about that. Inductive is when you notice something happening and you make a conclusion based on that for the general case. So you visually see it, right? You see something occurring multiple times. And then we did talk about converse, inverse, contrapositive earlier. So we've covered that. And we did talk about counterexamples. So we still have a few things left. You'll see here we need to cover deductive reasoning, which we're going to get to that in the next video. Okay, that's it for today, guys. So you have this very, very short assignment. Make sure you get that finished and turned in on Canvas. And that's it, guys. Message me if you have any questions. And as always, I recommend printing off the notes for the next one as well. All right, have a great day. See you later.